Hey guys, so this is going to be a short video. I just wanted to go through how to randomize and kind of control clusters of pieces. And so I just wanted to kind of very quickly go through like how I created this system. So here we have just a very simple grid, and I'm not going to go through how to fracture, but briefly it's a grid with scatter points. We have orient set to 4, since orient is of course a 4 vector type of attribute. This is just very quickly how you randomize it. Copy to points, mountain, and then you Boolean fracture it. Because this is a surface, it has no thickness to it, you would just set this to surface inside of here, surface, okay? And then I'm just caching that out. So what we have is, let me clear this, reset viewport, so now I can see the gray. So we have our pieces here and here, and we want to randomize the cluster. Now the problem, let's go here, just to show you like this is still will work in an undefined space. So when you go to RBD cluster, by default, let me go here. Oh, I hate that it does that. Let me save that by default. So by default, it only gives you one single noise. You can't really tweak this. And I've always found this really frustrating. What I've done in the past is I would come inside of here. I would say this is a preset, but I would come inside of here, and this is the bulk of how the clusters are being assigned. It's just a noise pattern. So what I would do previously is I would say, okay, let me just copy this, and basically I would create another frequency like 2 as a channel, and basically you just need to modify this to be like 2 and, or not that, sorry, but like seed 2, and you create another seed 1, and basically you just add seed 1 and seed 2. Sorry, this would be seed 2. Okay, this is basically what you would do. And your frequency would be frequency 2 equals 1 divided by new size, you know? This would kind of be how I would do it. But this doesn't really give you a lot of control, and it's just not very, like, this kind of works, but not really. Like, it doesn't really give you a lot of control. So I wanted a way to really give myself some control. And I found this technique, not I found it, but I figured it out actually in a shot. Like my effects director was like, hey, can you make this so that, you know, some of the pieces are larger and other pieces are smaller. And we already had a defined fracture, so I couldn't, I mean, I guess I could have fractured this again, but then, you know, you have potential issues with, oh, like it's not fracturing correctly, or maybe the name attribute's messing up, that type of thing. So I needed to find a way to do it with clusters. And so this was kind of the solution that I found, like this type of solution. I don't know what's on today. So we're gonna set this part up. So eventually I might figure out a way to do it outside of the network, and you totally can. Like if you do the setup here and feed it in, and then you kind of just do like an attribute copy this to this, and you would just set this to primitives, and you would just say name and cluster. So this is basically how you would do it if I were to do the setup in here, like up here, instead of inside of here. That's kind of how I would do it, because we're going to be modifying like the position. Actually, you know what? Let's try it. I'm going to keep this, but I'm going to kind of duplicate this and say match current definition, and we'll just do it from here. Let's try it. What we want is if I look at this and I scale this up, or down rather, you can see that as I scale it up and down, it's defining the clusters differently. And that's because inside of here, like I showed you, there's this noise that's being applied here. So if you change the scale of the position in some way, then that's going to change how this noise gets outputted, because it's already being multiplied here. So, but if you can modify it further, then you can really change how this noise is being constructed. That's why whenever you are changing the scale of the position here, it also works. So the smaller the scale of the position, you can see what's happening, like it's obviously scaling it down, the more of a chance that the pieces have of entering into that particular cell of the cluster. And so that's why as you scale it down, the pieces become larger, because more of the pieces have a chance to enter into that cell, that particular cell that's in world space. As you scale it up, less pieces have a chance to enter into that cell of the noise pattern. So we need a way to customize this. So let's try it. So what I found, you can actually, and we can't skew it, because originally I did a magnet. If you scatter points, you copy 2 points, a metaball from these points, from the scattered points on the geometry, copied one single metaball, copy the points, and you use this as your deformer and this as your magnet. What you can do is you can actually scale it up like this. So, but the problem is this causes a distortion, as you can see. It causes a distortion, and we can't have that. Actually, this actually needs to take place. So we need to go in, for this to work, we need to actually go inside of here and kind of do what they're doing. So let's do that. We're gonna do that here. Let's see, and then this, and this isn't working because is the name actually created? Yes, it is. It's on the primitive level, and let's get rid of this. Ah, yes, it's because, okay, so this is something that I found. It's very, very cool. So if you have a centroid like this and you want to transform pieces, what I found that's super cool is when I was studying the extract transform node, this will actually give you what's missing. Let's see, if I do this and this, usually what I'm doing is I'm time shifting one frame. So if you do this, but what you notice is it gives you a bunch of attributes. It gives you name, it gives you orient, it gives you P, and finally what's really important is pivot. Pivot is the key to this extract transform, because if you do transform pieces after this and you set P scale here, you can see what happens. Like all your pieces will suddenly get scaled down, right? And that's because this is setting pivot. If I were to clear pivot, it does the same thing that this was doing, right? Same thing. Well, minus the P scale. Same thing, right? Basically the same thing. And the reason for that is because it no longer has that pivot. It needs that pivot. So that's what I discovered. So this thing sets that pivot, and all the pivot is the position. If you look here, position is this. Let me show you. So if I say pivot and P, they're exactly the same. So all it's doing is it's taking position and making it into pivot. Okay, that's the wonderful trick that this thing does. So whenever you, and this is a trick that I used to do all the time until I realized, oh wait a minute, the only difference is that it's doing pivot. So I can just simply, if I have a bunch of points like this and they have the same, and they have the pivot attribute, it'll work just the same. And that way, because this actually gets rid of a bunch of attributes and it calculates its own orient, which we don't want. If you happen to have your own custom orient here, it would overwrite it. That's why I don't like this method anymore, because now that I know kind of how to do it, you don't need it. I mean, it's still extremely useful in certain cases, absolutely. Super great for like really fast doing things like this. It's great because it automatically calculates all that stuff for you. It's still extremely useful, but if you just need a pivot, then you don't need to use this. I showed you that. All we need to do is say pivot is equal to position. And now if I adjust P scale, this, you can see we are scaling each piece down randomly based on this noise, right? And you can do some pretty cool stuff with this, right? All right, so we're going to use the same technique, but instead of P scale, we don't want to modify P scale. We want to modify the global scale of each name. So match current definition. What we want to keep this pivot, but what we want to do is basically scale. We want to magnet this, but this doesn't quite work because it's distorting it. Like it kind of works, right? Like it is pushing pieces away, but you can see that it's kind of distorting it. Like the pieces that are closer to the Metaball are going to be distorted more than the pieces that are further away, and so there's a gradient. There's like a fall off, and we don't want the fall off. So that's why this isn't going to work as well. We want there not to be a fall off. We need it to be like very structured. So what we can do, let me make sure this works first. Hang on. Yes, cool. It actually does work. That's awesome. So yeah, it does work. It's just clunky and it's just not great. So we need a way to modify this much better. So let's do that. So what we want to do instead of this Metaball and this magnet, let's actually get rid of that. What we want to do is we want to kind of like define areas that we want to scale in and then scale those areas in uniformly. And we're going to actually use the transform pieces for that. So what you can do is I showed you this method, but what we actually want to do is do a step further. So not so much here, more like here. We want to define this area differently. I'm going to steal this, and what we can do is say cluster points. This is just one method. You can do many others. So cluster points will give you a cluster attribute. It's a random integer from 0 to the number of it's not random, but it's using something called K clustering, and it's actually using the same. It seems to use the same algorithm that like near points does. I think they both use the same algorithm to search nearby points. So 0, it goes from 0 to the number of clusters you have. So 7, it would be 7 because it starts at 0, not at 1. So we have 8 clusters here, and what we want to do is uniformly scale them in. So we already used this node. Let's actually use this node again. But instead of name, which we already have, we're gonna use point, and we're gonna say instead of name, we're gonna use cluster. So now we have 1 point for every cluster in here, right? In the center of each cluster. Now what we want to do is I'm actually gonna steal this. I'm gonna put it over here, and that way the pivot of each cluster is at the position of each cluster. And so that way we can uniformly scale this. So let's do this now. Let's do transform pieces, and let's do this. And then what we can do, since these are our cluster points and they have that pivot, we can also assign p-scale to this based on a noise. Okay, and when we do this, it doesn't work. And that's because this is matched by attribute. So previously it was looking at the name attribute, and so this technically is working, but it's looking at itself, so that's why nothing's happening. But we need to tell it not to match by name, but by cluster. So we need to say, hey, like look at the single point that this is coming from, this cluster, match it by that, and tell me what the p-scale is, and then scale all my points in by that. So let's do that. Let's not by name, but by cluster. Okay, and now you're getting something very interesting. Now you're getting p-scale uniformly changing by the cluster, and you can modify this. Now, when you plug this into here, and the pivot is now here, now you're gonna see our geometry change to this. Or not. You know, it could just also just not work at all. Cluster pivot. This is using the same name, but we have name. Pivot is P. Oh, pivot is P. So this is why it broke, because we're telling it that the new pivot is the position of the name. We can't have that. We need to put this up here so that the new pivot is where it was before. Otherwise, it's like, well, I'm just gonna copy it and put it exactly where it was before. Now this should work. Yes. Okay. So now when you modify this, each area gets scaled in and out. And that's actually really cool. But what's even better is doing this. So once we do this, each piece should get more or less the same, like bigger, smaller, whatever. Let's see. And so now when we modify this, it actually does change the cluster. Now this is an art still, because depending on how many clusters you have, if you have 4 clusters, the less clusters you have, the bigger pieces you're going to have, because each it's scaling more pieces into a central location like this instead of less pieces in a central location, if that makes sense. And I'm going to show you kind of how to remedy that. So now we have this, and that's based on this cluster. So if you have less, like I said, if you have less clusters, the bigger pieces you're going to get. If you have just 3 clusters or 2, you're going to get much bigger pieces, right? If you have more clusters, you have more variation kind of, but less chance of it to become smaller, right? Because you have less points overall scaling in the same area. What you can do to remedy that is the cluster points is currently set to position, and another way you can modify this is you can do one of 2 things. You can use position, or you can cluster by an index or something else, or you don't have, and cluster points is slow. So if you have another way of clustering, then that's better. One thing you could do is to simply create points where you need like bigger pieces and do that. So I'm gonna come over here and hit add, and I'm gonna create a point, and I'm gonna template this and look at this and make sure this guy is set to display show current operator, and then I'll make sure that whatever node you're highlighting, it'll allow for the tool to work for that node. If you didn't have this on, it's actually great for performance, because sometimes you might highlight a node and be like, oh no, it's calculating, I don't want it to calculate. This is how you make sure it doesn't calculate, and this is in your preferences if you want to look. It's in your Houdini preferences. It's in here. So here's another nice trick. You can snap, hit enter to go into the tool for the moving of this point, and you can middle click on a point that you have displayed or hard templated, or templated, I think. Let me see. Does it work with templates? Let's see if it works with templates. It might. Oh yeah, it does. It works with templates. And I think that's due to, if you right click on this, let's see, is it based on template guide? X-ray, maybe? Templates, yes, that's why. So this is a really nice trick. It works with everything. Sphere, like if I had a sphere, I did the same thing, it works for that too. So this is a really handy trick that I wish everyone knew. I don't see a lot of people talking about it, so that's why I'm explaining it. So you can create a bunch of points here. Like let's say you want a big chunk here, maybe another big chunk here, maybe one more like maybe here, and then you can just alt click on the output and drag down. You get a merge, and then we can do an enumerate based on the point, and we can actually, instead of using cluster points, we can use attribute transfer and just simply, actually we can just call this cluster, and then when you attribute transfer, kind of does the same thing. So we're just going to say cluster here, cut this off, and you can change the sampling here. Now in this case it doesn't really matter, there's only 3 points, but if you had more points this would make a difference for sure. And then we can scale in those pieces, and so now you get a lot more like defined areas. This is kind of how you can like really customize it, right? And we can add more points. So let's say we want, okay, actually I want another point, but instead of here I want it like, say like here or here or something, right? And let's say we want one more, and maybe it's like here, like we want to define it here, right? And now you're getting like this. This is kind of how it looks. And these are our clusters. These are our new cluster solution, right? And so now you're able to kind of more control how where your bigger pieces are. Now, let's say you're not happy with this solution, like, because I wasn't, because my director was like, actually, I want larger pieces in the middle and smaller pieces on the edge. Can you do that? And I was like, yeah, sure. So what I did was I just took a mask here, and let's say I like painted it here, just a mask, and instead of cluster, well actually no, cluster is still a good idea, but what I did, let's see, it should already have, it might not be transferring mask over, so let's transfer mask over. I don't see mask, so let's just attribute transfer that mask over. I'm not sure why it's not being transferred. That's okay. Possibly it's because it's not name related, like piece related. And here would probably make a difference. See, yeah, see, so here it does make a difference. If you want less definition, kinda, like this is good for like sharper qualities, but if you want it like kind of blurred, little bit. This is how you would do that, kind of like blurring it, kind of sort of. So we have that mask, and well, you can actually just use mask. So instead of you can actually just say instead of position, you can actually say mask, and that would create a few clusters in here. This might work, not sure. Okay, but you don't want it random. You want each, you don't want it random. So in this case, what I would do is I would actually blend between this and a p-scale of 1. We would just say constant, make this 1 at set always, and this is set always. And then I would blend between this guy and this guy based on the mask. So based on first input, based on the mask, and it's not working. Let's figure out why. It's because, again, this transfer needs to happen here as well, and it's because this let's actually just transfer over this cluster we did before, and we don't have any points in the middle, so we need to change that to be different. Let's have a point right here in the middle, maybe another one in the middle, and then when we add these here, kind of works. I mean, you get my drift. Like, this is kind of how you would do it, right? This isn't quite what I was after. Let's just cluster the pieces, and now you have like a lot more control, right? This is probably too many points. Let's do less. So you can, it is still an art. You still have to define stuff yourself, but it's definitely better than what it was before, where you had like no control over the size of the pieces. But like I said, it's still an art. Like, you still have to play with it and get the right values. So yeah, I just wanted to quickly show how to do this. And we were able to do it without editing the clusters. That's nice. We basically did this twice. We did it here. We did it here to modify each piece. Wait, one thing I'm worried about is the p-scale. So let's make sure the p-scale is not coming through. P-scale, cluster, because it could be defining, because I'm not sure if it actually, yeah, it's transferring everything. P-scale. Oh, there is no p-scale. Okay, that's good to know. I just wanted to make sure it's not changing that at all. You know what I mean? So I still don't, like, let's say if you wanted a bigger piece in the middle, you just have to reduce the clusters. Might still be too much. And then, yeah, and then you can like paint it. Oh, one thing I also wanted to go over is setting there's a random detach. So this you would have to go inside for, but basically I hate this, but you don't want it random. You want it based on like maybe like the length of the mask. So if that mask is actually coming through, which it definitely should be, and it's not. Attribute transfer from here to here. Just switch those inputs. Here, mask. Right, there we are. And we can just say, hey, if it's outside the range of the mask, make cluster equal -1. So we'll just say, if mask is less than 0.1, then cluster is equal to -1. And the reason I'm doing it in here is because I don't quite know what's going to happen. It does a lot of stuff, so I don't want to do it outside of here. So if you don't have it on, obviously this isn't going to do anything now because we disabled that node. But this is just to make sure, like, if you don't want clustering happening anywhere else, then you can just turn this on, and it will make sure that all the other pieces are not glued together if you only wanted it to cluster within this area. So just wanted to show you that. That's really important as well, because you can't, I don't think we're able to say just like cluster is -1 and it worked. Yeah, because it's doing all that stuff internally. Anyway guys, that's my tutorial for custom clustering, and I hope you found it useful. I am hoping to put a few more tutorials out there, but if you guys have any ideas of what you want to see, just let me know. Thank you very much, and I will talk to you guys later.